Welcome back to another video of our data science playlist. In this video, we will be discussing about the phase model evolution. So let's get started. This video will explore model evolution, its importance in data science, and how to implement different techniques using Python. We will examine different matrices, discuss the concept of unequal error cost, and provide illustrative code snippets. Now, let us understand what model evolution is. So, model evolution is a critical step in data science where we assess the performance of a machine learning model using various matrices. The choice of matrices depends on the type of problem you are solving, whether it's classification, regression, or any type of task. Evaluation classification models in Python. So, the common matrices like accuracy, precision, recall, and F1 score provide insights into a model's performance and help to understand its strengths and weaknesses. Now, key evaluation matrices. The evaluation matrix you choose depends on the type of problem you are solving, whether it's classification, regression, or other type of models. For classification problems predicting discrete classes such as spam versus non-spam, disease versus no disease, the most common matrices that we use are accuracy, precision, recall, and F1 score and confusion matrix. In accuracy, the proportion of correct prediction out of all prediction is calculated. This is the formula for calculating the accuracy matrix where TP stands for true positive, TN stands for true negative, FV for false positive, and FN stands for false negatives. Now, our second matrix that is used for classification model evaluation is precision. It is defined as the proportion of correctly predicted positive observations among all predicted positives. The formula for precision is given and it is useful when the cost of false positive is high. It means that the false positive value is higher than the true positive value. The recall matrix or sensitivity or true positive rate is defined as the proportion of correctly predicted positive observations among all actual positives. Now, F1 score is defined as the harmonic mean of precision and recall. It balances both matrices and is a good measure when there is an uneven class distribution. The formula for F1 score is F equals to 2 into precision into recall upon precision plus recall. Confusion matrix is defined as a matrix showing the performance of classification mode. It compares the predicted classification with the actual classification. Now, regression model evaluation. For regression problems, predicting continuous values such as house prices or temperature, the key evaluation matrices are mean squared error, mean absolute error, and root mean square error. Before understanding these matrices, let us first run codes for these matrices that are used for classification problem. For accuracy matrix, the code, we are importing some libraries and generating a synthetic data set, splitting a data set into training and testing sets, now making predictions on the test set and calculating the accuracy of our test. So the accuracy for this is 90%. Now, for precision, let us run this code that explains the concept of precision, that how much precision does our model has, and the calculated precision is 94.85%. Let us run the code for recall, and the recall is 85.98% for the predictive model, and F1 score is calculated as 90.3. 20%. And the value for confusion matrix for the same will be 85.5 and 1592. Now let us talk about the matrices that are used for regression model evaluation. First is mean absolute error MAE. The average of the absolute difference between predicted and actual value is defined as the mean absolute error. A lower value of MAE indicates better performance. Means the less the mean absolute error will be, our uh, model will be more accurate. Now, mean squared error MSE. It is defined as the average of the squared differences between predicted and actual values. MSE punishes larger error more than MAE. Root means squared error. Definition: the root the square root of MSE which gives a result in the same unit as the target variable. Now let us try running codes for these three matrices. For mean absolute error, the mean absolute error is calculated as 0.10. That means the model is giving accurate values. The value for MSE is also 0.10, and the root mean squared error is 0.30. Now, let us talk about the third type of model, that is model selection and cross validation. To ensure that your model perform well and is not overfitting, you should evaluate it using techniques like cross validation. This divides the data into multiple subsets and trains the model on different combination of these subsets, reducing the variance of our evaluation matrices. Now let us try running code for model selection and cross validation. Now for the example of model selection is k-fold cross validation. Let us run this code. The cross validation score 0.93, 0.905, 0.9, 0.9, and so the mean CV score is given as 0.898999. So this is the value for the cross validation. Let us understand model evaluation. Evaluate means accessing the performance of different models using various matrices and visualization. Optimize. We need to optimize our model. So, tune model parameters and hyperparameters based on evaluation result to enhance the performance. We have to enhance our model according to the results given by the matrices. Now deploy. Deploy is the last stage of model evaluation in which we deploy the chosen model for real world use and monitor its performance in production. So that's all for the video. Thank you for watching.